This long-awaited second part is about the biggest passenger plane in history. Now, new videos are released first on my YouTube channel, subscribe via the link in the description. This plane became the largest passenger liner in history, yet it turned out to be one of the riskiest aviation projects. It impresses with its size, technology, and onboard comfort, but its creation cost Airbus tens of billions. This is the Airbus A380, and today 50 facts that reveal its true story. Fact 1 * 22 wheels. To withstand the enormous weight of the Airbus A380, it uses a complex landing gear system. It has 22 wheels distributed between the nose and main landing gear. This design helps evenly distribute the load during takeoff and landing. A plane weighing hundreds of tons cannot rely on just a few wheels like regular airliners. So engineers had to develop a special landing gear system capable of handling colossal loads. Fact 2 * weight of nearly 600 tons. The maximum takeoff weight of the Airbus A380 reaches about 575 tons. This makes it one of the heaviest civilian aircraft in aviation history. For comparison, many modern passenger liners weigh almost half as much. Yet all this mass must not just roll down a runway but accelerate to the required speed and lift into the air, making this plane a serious engineering challenge. Fact 3 * evacuation of over 850 people. According to aviation regulations, a fully loaded passenger plane must be evacuated in under 90 seconds, even if half of the emergency exits are considered blocked. For the Airbus A380, this is an especially tough task, as the plane can carry more than 850 passengers. During certification tests, Airbus conducted a real drill. The plane was filled with 850 volunteers, and all of them exited in just 78 seconds. Meeting the strict safety requirements. Fact 4 * over 500 kilometers of wiring. Inside the Airbus A380 runs more than 500 kilometers of electrical wiring, around 530 kilometers of cables. This vast network powers control systems, lighting, navigation, communications, and passenger entertainment. The complexity of the electrical system became one of the reasons for delays in the A380 program. Early on, engineers had to redesign part of the wiring. Fact 5 * one of the quietest giants. Despite its massive size and 4 powerful engines, the Airbus A380 is considered one of the quietest large passenger planes. Engineers paid close attention to wing aerodynamics, engine design, and cabin soundproofing. As a result, noise levels both inside the plane and around it during takeoff and landing are noticeably lower than those of many previous wide-body airliners. Fact 6 * it was necessary to create sufficient lift for a plane weighing hundreds of tons. Its design uses modern materials and is meticulously optimized for aerodynamics. Fact 11 * wings bend in flight. In flight, the wingtips of the Airbus A380 can bend upward by about 3 to 4 meters. This isn't a defect but part of the design. The wings are intentionally made flexible to evenly distribute loads during turbulence and maneuvers. This wing behavior reduces stress on the structure and extends the plane's service life. When you see the wings gently moving in the air, it means the system is working exactly as engineers intended. Fact 12 * destruction test. Before certification, engineers conduct extreme tests. The Airbus A380's wing is loaded to 150% of its design load to check structural strength. In one such test, the wing was bent more than 7 meters upward before the structure reached its limit. This means the plane operates with a large safety margin in real conditions, which is critical for flight safety. Fact 13 * more than 4 million parts. The Airbus A380 consists of more than 4 million individual parts. This includes structural elements, control systems, electronics, interior components, and many other elements. Each part must meet strict quality and safety standards. Managing such a quantity is a massive engineering task requiring precise coordination between manufacturers and strict quality control at every assembly stage. Fact 14 * 1,500 companies. Around 1,500 companies worldwide participated in creating the Airbus A380. This is one of the largest collaborative projects in civil aviation. Each company is responsible for producing specific components, from large fuselage sections to small system parts. This distributed model allows combining the best technologies from different countries but significantly complicates production coordination. Fact 15 * production across Europe. The production of the Airbus A380 is distributed across several European countries. Major components are built in France, Germany, Spain, and the UK. For example, the wings are produced in the UK, fuselage sections in France and Germany, and the tail in Spain. This approach allows using specialized factories but requires complex logistics to assemble the plane in one location. Fact 16 * delivery by sea and road. Due to the enormous size of the Airbus A380 components, they cannot be transported by conventional means. Instead, they are shipped to France, Toulouse, by sea and along specially prepared routes. Some roads were even upgraded to handle the giant plane sections. This process became a separate engineering project without which A380 assembly would have been impossible. Fact 17 * over 17-hour flight. The Airbus A380 can stay in the air for more than 17 hours straight. Its maximum range reaches around powerful hubs, where the transportation of a large number of passengers over long distances is important. 18th. The cruising altitude is about 13 kilometers. During flight, the Airbus A380 climbs to an altitude of about 12 to 13 kilometers. At this altitude, the air is significantly thinner, which reduces drag and improves fuel efficiency. Additionally, flying at such altitudes allows the aircraft to avoid most weather phenomena, ensuring a more stable and comfortable flight for passengers. 19th. ICO Code F category. Due to its size, the Airbus A380 belongs to the ICO Code F category. This is the largest category of civil aircraft. It defines requirements for taxiway width, parking size, and airport infrastructure. Not every airport meets these standards, so operating the A380 requires specially prepared conditions. 20th. Limited number of airports. Only about 140 airports worldwide can fully accommodate the Airbus A380. This requires reinforced runways, expanded taxiways, and special parking stands. Many airports underwent costly upgrades to meet the aircraft's requirements. The limited infrastructure became one of the factors influencing the A380's adoption. 21st. Two-level jet bridges at many airports for the Airbus A380 required the installation of two-level jet bridges. This allows passengers to board and disembark simultaneously from both decks of the aircraft. Without such a system, boarding could take significantly longer. Such solutions became necessary due to the A380's unique design and enormous capacity. More than 320,000 liters of fuel. The Airbus A380 can carry about 320,000 liters of aviation fuel. When fully fueled, its weight reaches approximately 250 tons, making up nearly half of the aircraft's takeoff weight. Such a fuel reserve is necessary for ultra-long-haul flights that can last over 15 hours without landing. Fuel redistribution system. During flight, special pumping systems automatically transfer fuel between tanks. This is done to maintain proper aircraft balance and optimize aerodynamics. Thanks to this, the aircraft maintains stability and efficiency throughout the flight, despite the gradual reduction of fuel mass. Speed of about 900 km per hour. The cruising speed of the Airbus A380 is about 900 km per hour. This is a standard figure for long-haul airliners. At this speed, the aircraft can efficiently cover vast distances while balancing fuel consumption and travel time. Fly-by-wire system. The Airbus A380 is controlled using a fly-by-wire system. This means that pilot commands are transmitted not through mechanical linkages but as electronic signals. Computers process the pilot's actions and adjust them, ensuring more precise and safer aircraft control. Sidestick controls. Instead of a traditional control column, the Airbus A380 uses sidestick controls, a signature feature of Airbus aircraft. This system frees up space in the cockpit and allows pilots to control the aircraft using a more compact and convenient interface. Costly airport upgrades. To accommodate the Airbus A380, many airports had to undergo major upgrades. Some spent hundreds of millions of dollars expanding gates, reinforcing surfaces, and modifying infrastructure. This again highlights how unusual and demanding this aircraft turned out to be. More than 800 passengers. In its maximum configuration, the Airbus A380 can carry over 800 passengers. This is an absolute record for commercial aviation. Such capacity allows airlines to transport vast numbers of people between major global hubs in a single flight. One of the most expensive projects. The development of the Airbus A380 became one of the most expensive programs in aviation history. The total project cost exceeded 18 billion euros, and some estimates put it even higher. Production delays and technical challenges made this project extremely difficult from a financial standpoint. Only 251 aircraft. Despite its ambitions and scale, Airbus built just 251 A380 aircraft. It was expected that there would be many more, but the aviation market changed. Airlines began favoring smaller, more economical aircraft, reducing demand for such giants. First flight in 2005. The Airbus A380's maiden flight took place on April 27, 2005, and became one of the most anticipated events in modern aviation. The tests were conducted in Toulouse, home to one of Airbus' main centers. A prototype took to the skies in front of thousands of onlookers, both on-site and via live broadcasts worldwide. The flight lasted about 4 hours, during which the aircraft's flight control systems, stability, and behavior in the air were tested. This moment confirmed that one of the most ambitious aviation projects was truly capable of flight. First commercial flight in 2007. After a series of tests and certifications, the Airbus A380 entered commercial service in 2007. The first flight was operated by Singapore Airlines on the Singapore-Sydney route. The event generated huge interest. Tickets for the inaugural flight were sold through an auction, and many passengers paid far more than the usual price to be part of history. The Airbus A380 needs to accelerate to a speed of about 280 to 300 km per hour. Given its mass, this process takes more time and requires a long runway. During acceleration, pilots carefully monitor engine parameters, speed, and the aircraft's condition. Only after reaching the necessary speed does a smooth liftoff occur, which passengers often experience as surprisingly gentle, despite the plane's scale. 35th. Length over 72 meters. The Airbus A380's length is about 72.7 meters long, comparable to a football field without goalposts or an entire city block. This length allows for 2 full decks, a massive passenger capacity, and extensive cargo holds. Yet, the structure must maintain strength and stability despite its size. 36th. Height like a building. The Airbus A380 stands about 24 meters tall, equivalent to a 7 to 8-story residential building. When parked at the gate, it towers over most airport equipment. Special boarding bridges and ground support equipment are required to accommodate its height. 37th. Composite materials. Engineers extensively used composite materials in the Airbus A380's construction. These materials are lighter than traditional aluminum yet stronger, reducing overall weight and improving efficiency. Composites are used in the wings, tail, and other components. 38th. Advanced air conditioning system. The Airbus A380 features one of the most advanced air conditioning systems available. It provides comfort for hundreds of passengers across 2 decks, regulating temperature, pressure, and humidity to maintain stable conditions during long flights. 39th. Cabin pressure comfort. During flight, cabin pressure is maintained at about 2,400 meters, significantly more comfortable than the real conditions at altitudes over 12 kilometers. This reduces passenger fatigue and makes long flights more bearable. 40th. Spacious cargo holds. In addition to passengers, the Airbus A380 carries vast amounts of baggage and cargo. The lower deck accommodates standard aviation containers, making the aircraft both a passenger and partially a cargo plane, enhancing its efficiency. 41st. Turbulence stability. Thanks to its size and mass, the Airbus A380 is highly stable in turbulence. Turbulent zones feel gentler compared to smaller aircraft, resulting in a more comfortable flight experience. 42nd. Efficiency per passenger. Despite its high fuel consumption, the A380 can be efficient on a per-passenger basis. At full capacity, it transports hundreds of people in a single flight, reducing the cost per traveler. 43rd. Hub-and-spoke model. The A380 was designed around the hub-and-spoke model, where passengers travel between major airports. However, the market later shifted toward direct flights, reducing the relevance of this concept. 44th. Difficulty and profitability. The project was extremely expensive, and profitability became a major challenge. High development costs and limited demand made the program financially difficult. 45th. End of production. Airbus A380 production ended in 2021. The last aircraft was delivered to Emirates, the largest operator of this model. 46th. Emirates commitment. Emirates made the biggest bet on the A380, using it extensively on long-haul routes and making it a globally recognizable aircraft. 47th. High level of comfort. The Airbus A380 is considered one of the most comfortable aircraft, offering personal space comparable to a hotel room at 12 kilometers altitude. 49th. Symbol of its era. The Airbus A380 became a symbol of an era of giants. It represented the peak of engineering ambition and human aspiration. 50th fact. You should write this yourself in the comments, as I must have missed something. Despite its commercial failure, the Airbus A380 remains a true embodiment of modern aviation. It is a plane where engineering boldness, technology, and humanity's drive to push boundaries converged. That is why the A380 will remain not just an aircraft but a symbol of an era when humanity endeavored to achieve the impossible, and succeeded.